Zalot Studio channel is set on simulation virtual physics lab. Geostationary satellite. Geo means the Earth that stationary relative velocities of the Earth with the artificial satellite is zeros. Stationary mean the velocity is zero. That means the relative velocity, which means the relative velocity of the Earth and the artificial satellite is zero. When so geostationary satellite, a satellite that orbits the equator of the Earth, orbits at equator within the same angular velocity as the Earth, it occurs. The geostationary of satellite is occur at that condition. So orbital velocity of a satellite, the orbital mean the angular velocity of a satellite. A satellite have orbits that are always moving relative to the Earth. Many of these are used to look down on the Earth. Some of the military spy satellites. This is the use of satellites. Some of the satellites that escape into the satellite within the orbits, okay, the right out of the Earth's potential, and that escaping completely and to reach the orbits. So for the use of military service and but other for the other observation of the Earth's weather, the weather, so agricultural purpose over the whole globe, and etc. for different purpose. For different purpose, the satellites, the artificial satellites, can be escaped into the surface on the surface of the out of the surface of the Earth, that revolving the orbit around the Earth. So all satellites are in orbit that are distance from the Earth with an h height of the satellite, that between the surface of the Earth and the satellite. Each satellite move at a particular velocities in its orbit. It is the original or the orbital velocities, which is the angular velocities, is geostationary satellite, that 2 pi over t, where omega mean the angular velocity and t mean it's the period to complete one revolution, the time to complete one revolution, or the satellite to complete one revolution. The escape velocity of the satellite. If a satellite is launching vertically upward at a sufficient large velocity, vertical velocity, it will able to climb right out of the Earth's potential well and escape completely. Okay, that's the potential. The Earth's potential is mean the gravity. So the escape velocity of the satellite is the speed it need to escape the potential will of the Earth. Thus the escaping velocity v is equals under root of 2 times g, that's the gravitational potential, and times the radius of the Earth, the radius of the Earth. Okay. Zalot Studio channel is focused on virtual physics lab. Yeah, today's lesson, that is universal gravitational force. The universal gravitational force, or Newton's universal gravitation, or the forces of gravity between the two bodies. This is the planet of the stars, that is the sun, and the planet that of the Earth. Okay, if the pause, okay, the Earth is that revolving the sun in 365 days, Earth a day, and here, okay, the moon revolve around the sun. Here is a pause. Oh, make it a dramatical pause. Okay, and the sun that around the earth is in 365 days in earth days. Okay, also this one is the velocities or tangential velocity of the moon and tangential velocity of the earth. Again, one, the moon with the earth. This is a planet of the earth and the planet that is the moon. Here our planet that is moon, our moon, and the planet of the earth. Here the universal gravitational force between the two bodies or the two planets, that's earth and moon. Here the artificial satellites that revolving around the earth, when the earth is stationary, the satellite that revolving within the earth's minute to complete one revolution in 90 minutes, which is 1 hour and a half. Okay, this is today's lesson within scale. Here the scale of the sun and the scale of the moon. Okay, the mass of the earth that relate with the moon, the mass of the sun that relate with the sun, that is 333,000 earth's mass. Oh, it's very big, very big. The mass of the sun is very big, very big. Okay, and the earth's mass, when the earth's mass is 1, the mass of the earth is 333,000 is greater than the mass of the earth. And here also the mass is great, 1/100 times of the mass of the earth. Okay, also here the planets of the earth and the moon. Near the moon again the artificial planets. Oh, 40 billion space station masses. Okay, the earth's mass is 1 times that is 1 space station mass, and the satellite mass that is 40 billion and billion space station masses. Okay, this is all about Salot Studio channel is focused on virtual physics lab. It's an artificial satellite, artificial space station satellite that revolve around the earth, and this one is earth's space mass of that is 14 billion space station mass that relate with the artificial satellite, that much bigger. So this artificial satellite here, the planet, our planet, that the earth, and our moon that is much less mass with relate with the earth's. Okay, this is a revolving path of the moon that rotating about the orbit of the moon within 28 days to complete 1 revolution. Okay, the moon that revolve 1 revolution about the earth within 28 days. Here our star that is sun, which is much greater, which is 333,000 earth mass greater, and the mass of the earth is 1. So the Earth's within the Earth's day, the Earth revolving around to complete one revolution in 365 days. Here it is, the Sun within the Earth, the universal gravitational force between the Earth and the Sun. Here, force of gravity that G times m1 m2 over r square. R square means the radius between the center of the Earth to the center of the star or the Sun. So there is a force between the attraction force between the two satellites, the two planets, that the star and the planet of the Earth, between them. Okay.